So welcome to Unit 3 National 5 Chemistry, and the topic that we're going to be looking at in this video is metals. So this video is going to be an introduction to metals. It'll be revision of metallic bonding and also looking at the reactions of metals with water, with acid, and with oxygen. So metals contain a particular type of bonding, and remember, we know all the types of bonding from Unit 1. So we know ionic bonding, the electrostatic force of attraction between positive metal ion and a negative non-metal ion. We also know about covalent bonding, which is the electrostatic force of attraction between the shared pair of electrons and two positive nuclei. And covalent bonding exists primarily for non-metal elements. And covalent bonding comes into two types. We've got covalent networks, where we have lots of covalent bonds in a lattice, so a structure that goes on and on and on and on and on. And then we have covalent molecules, where you're always able to count the number of atoms in that molecule. And there are strong bonds between those atoms, but weak bonds between the molecules, which means that covalent molecules have low melting and boiling points. The type of bonding in metals is called metallic bonding, and it is the electrostatic force of attraction between positively charged ions and delocalized electrons. So in your diagram that you have here, these larger ones, those are your metals. And these small ones, you can sometimes, instead of drawing a small circle with a negative, you can draw it as an E standing for electron, and just make sure that you put the negative charge on it. And you can see that the electrons are not organized in any particular way, and that is because delocalized means that they are free to move. Now, metals have a unique property of being able to conduct electricity regardless of whether they are a solid or a liquid. Metals can always conduct electricity. The reason for this is because that those metals contain your delocalized electrons. And that term, delocalized electrons, is what examiners are going to be looking for if you're being asked a question about conductivity of metals. Now, delocalized electrons means that they are free to move. So free to move, if you write they have space to move, that is wrong. It is that they are free to move. In other words, they can move. Just because something has space to move doesn't mean that it can move. So make sure that you say they are free to move, not that they have space to move. Next, we're going to move on to how metals react. And some metals, such as alkaline metals, have to be stored under oil. This is because they are so reactive. And such metals react with acids, water, and oxygen in the air. And what if a metal is reacting? How would you see that? Well, when reactive metals react, they are being broken down, and you will always see chemical reactions happening on the surface of the metal. So if it's a very vigorous reaction, you will probably see lots of bubbles on the surface of the metal. If it is a slower reaction and maybe a less reactive metal, you could see some slow bubbling, but you might also see change in color of the metal. Now, when it comes to metals, we are going to look at how metals react with water, a very unreactive chemical, with acids, which are reactive chemicals, and with oxygen, a very reactive chemical. We're going to learn what forms, and we're going to learn the general equations for these. So the first thing we're going to look at is metals reacting with water. Because water is so unreactive, it requires very reactive metals to get this reaction to happen. And when a metal reacts with water, the products are the metal hydroxide and hydrogen. So for example, lithium plus water goes to lithium hydroxide plus hydrogen. So what happens is if you've got a water molecule like this, and the other one like this, those two hydrogens go here, and what you get left with are two hydroxides, which go here, and then the lithium's doing that. So you don't need to know that detail of what's happening with the water molecules, but I've drawn that in because it can help you understand how you end up with hydrogen and how you end up with hydroxides. That the metal is splitting the water apart to produce hydroxide and hydrogen. And remember, you can test for that hydrogen gas by lighting it on fire, and you should hear that characteristic squeaky pop. And when it comes to metals reacting with water, it is only the most reactive metals. So every element, every metal in group 1, the alkali metals, and some metals in group 2 can react, but group 2 metals, if they react with water, the water has to be very hot, if not boiling or steam. It is important for us on Earth that not all metals react with water, because we have lots of devices and lots of jewelry and other things that we would wear that are made of metal, and that would be destroyed if it rained. We also wouldn't be able to have cars, planes, etc. if every metal reacted with water. And in fact, the majority of metals do not. So next, we're going to look at metals reacting with oxygen. Now, oxygen is a very, very reactive element, and oxygen can react with even some very unreactive metals. Now, you get no hydrogen whenever you react a metal with oxygen. In fact, you get the metal oxide. So this is very easy to see how it reacts. Metal plus oxygen produces a metal oxide. So for example, iron reacting with oxygen forms iron oxide. And the only metal that doesn't really react with oxygen is gold. All the other elements, metal elements are able to react with oxygen. And so silver in your list of metals is really the last one that can react with oxygen in the air. So mercury, as well as gold, is unable to react with oxygen. The higher you are on the reactivity series, and we will look at the reactivity series at the end, the more vigorous. So if a metal can react with water, it will react very violently with oxygen. In fact, metals like potassium, sodium, and lithium need to be stored under oil so that they're not exposed to oxygen in the air, because they could react very quickly. If you want to produce pure oxygen, rather than just reacting oxygen with the oxygen in the air, remember the air is 20% oxygen, just slightly under 20%. If you want to produce pure oxygen, there is a way to do it. And the way to do it is to heat up a chemical called potassium permanganate. Now, permanganate it contains 4 atoms of oxygen in it, and when you heat it up, it breaks apart and forms pure oxygen. If you have metal in the same container as the potassium permanganate, and you break down the permanganate by heating it up, that metal can then react with pure oxygen. And this is how we can get metals that are not so reactive, like silver, to react with oxygen by producing pure oxygen. Now, the final thing that we need to know is how metals react with acids. Now, from Unit 1, you should be very familiar with this equation. So whenever a metal reacts with acid, you're going to produce a salt and hydrogen. So metal plus acid goes to salted hydrogen. So for example, Magnesium plus hydrochloric acid forms magnesium chloride plus hydrogen. And there's the equation for it. You need to remember your process for naming salts. So when it comes to naming salts, we have to remember hydrochloric acid will produce metal chlorides, sulfuric acid will produce metal sulfates, and nitric acid will produce metal nitrates. So for example, zinc reacting with hydrochloric acid will produce zinc chloride and hydrogen. And how metal salts are produced is you react excess metal, so that means you add more metal than can react with your acid. Then you remove that excess metal by filtering it, and then you can get the salt by evaporating off the water, and that leaves behind the salt. Now to summarize, we've got our three equations. Metals react with oxygen to form metal oxides. Metals that react with water produce metal hydroxide and hydrogen. And metals react with acids to produce salt and hydrogen. Now, to summarize, this is the list of metals, the reactivity series, found at the back of your data booklet on the final page. Now the metals at the top, lithium, potassium, calcium and sodium, can all react with cold water, acid and oxygen. Magnesium can react with hot water, acid and oxygen. The next block of metals, from aluminium down to lead, those are metals that are reactive, but they can only react with acid and oxygen. We then have copper, silver and mercury, which can react with oxygen to a degree. Mercury doesn't always react with oxygen, you have to put a lot of energy into it. And those are our low reactive metals. And then we finally have gold, which honestly reacts with virtually nothing. Now, if you are paying close attention to your data booklet, you'll actually find that there is something else written here, and that is hydrogen. Now, hydrogen is written there for a reason, because hydrogen, remember H+, is acids. And anything above will react with acid. Anything below will not react. So just remember, the metals at the top are very reactive. They can react with water, acid and oxygen. The ones in the middle can react with acids and oxygen. The ones at the bottom can only react with oxygen. And then you've got gold and mercury that virtually react with nothing. So that has been your introduction to metals. We've gone over metallic bonding and we've gone over the reactions of metals.